Hi everyone, I hope you're okay. This is the sixth video, guys, of me answering the past exam question papers, but only under the topic of momentum and impulse. Please note that, guys, the other videos already uploaded. You can just click the link on the description below. It will direct you straight to the playlist whereby I have answered all the 11 questions. And the other playlist, guys, is for those who still want to learn momentum and impulse from scratch. Okay, before we even start, please, guys, don't forget to share this video to your peers. A thing or two mentioned here might help them, whether to elevate their knowledge, prepare them for an upcoming test or an upcoming exam. So don't forget to like as well, comment, and most importantly, please help us grow the channel by just subscribing. Okay, the diagram below shows two sections, XY and YZ, of a horizontal flat surface. Section XY is smooth, while section YZ is rough. A 5 kg block moving with the velocity of 4 meters per second to the right collides head-on with a stationary 3 kg block. After the collision, the two blocks stick together and move to the right past point Y. The combined blocks travel for 0.3 seconds from point Y before coming to a stop at point Z. Okay, we can call this object A and object B. No? First question, they want us to state the conservation of linear momentum in words. It simply states that in an isolated system, the total linear momentum is conserved in both magnitude and direction. Okay, and then 4.2.1, they want us to calculate the combined the magnitude of the velocity of the combined blocks at point Y. The magnitude of a velocity. Since path XY is a smooth surface, it simply means that we have an isolated system because we don't have non-conservative forces. So since we have an isolated system, I can simply say that the sum of the momentas before is equal to the sum of the momentas after collision. So it's the momentum of object A before collision plus the momentum of object B before collision, and then after collision they will move as one unit, so we'll find their momentum, their combined momentum. I know that object A is just 5 kg. Another thing, guys, the very important thing that I just omitted was to choose a positive direction. Since momentum is a vector quantity, choosing a positive direction is very, very helpful. Any direction towards the right or the eastern direction is positive, no? So that means the velocity of the 5 kg block is positive 4, and then I have a 3 kg which was stationary. That means the velocity is just 0 meters per second, and then I have 5 plus 3. I want to find the final velocity after collision. This will give me 28 VF. 20 divided by 8, I'll simply get a velocity of 2.5 meters per second. Since it's positive, that means it's moving towards the right. But here they only wanted me to find the magnitude, né? So the velocity is just 2.5 meters per second. Okay. And then the following question, they want us to find the net force. The the net force acting on the combined blocks while they move together through path YZ. I know that they will take 0.3 seconds to move there. So I can simply say F net multiplied by delta T is equals to the change in momentum. Together, I can rewrite this thing. Change in momentum can be written as M VF minus VI all over the change in delta T. The mass of the two blocks combined is 8 kilograms, and then their velocity, point Y will be initial, the initial point, and then point Z will be the final point. Their final velocity will be 0 meters per second, and then their initial velocity, we calculated it to be 2.5. The time it took for it to travel from that point, from point Y to Z, is 0.3. So I'll simply say 8 multiplied by 0 minus 2.5 all over 0.3. This will give me negative 66.67 newtons. Together. I was expecting to find a negative answer. Why? Because the only force acting on this surface is frictional force, and frictional force is opposing motion. Together. So since it's opposing motion, it has to be negative. So, but here they only wanted me to find the magnitude of the net force. I'll simply say, let me write in a different color. F net is just 66.67 newtons. That's how, guys, you're supposed to tackle that question. Just stay tuned, guys. Video number 7 is on its way.